Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to discuss a Biochemistry GAMSAT Section 3 unit. So this unit has 3 questions, and before we get the ball rolling, it's probably a good start if you pause the screen, have a read of the stimulus, and have a read of the questions. So I'll just flick through the 3 questions just so you can pause the screen and have a read. So this is question 1, question 2, and question 3. So before we begin, just have a quick read of the stimulus and those questions, and then we can get stuck in. Okay, cool. So once you've had a read of that, it's important to note that when we read the stimulus here, cardiolipin, it's a pretty unique structure. It exhibits this dimeric structure here with the 2 phosphatidyl moieties that has 4 acyl chains, so just 4 fatty acid chains joined here of any combination, and it's linked here in the center by glycerol. Another important factor we're told is that cardiolipin, it prefers polyunsaturated fatty acid species as the acyl subspecies that's joined to it. So keep that in mind because we're also given a table here at the bottom with common saturated and unsaturated fatty acids with the common name and the structural formula. But it's important to note here that I guess the trick is they don't tell you which the question doesn't tell you which molecule is saturated or unsaturated, or monounsaturated or polyunsaturated fatty acids. So just recall as well, in general chemistry, saturated means that the molecule fatty acid doesn't have any double bonds, whereas unsaturated means it has double bonds, whether it's monounsaturated or polyunsaturated. So mono means one double bond, poly means more than one. So just keep that in mind, so that when we read the first question, it kind of gives us a hint of how to answer it. So it says here, although cardiolipin's fatty acid composition varies across tissue types, polyunsaturated fatty acids, they dominate in the muscle tissue. So as we were told in stimulus, we're looking for polyunsaturated fatty acids here. It says here, using table 1, which fatty acid combinations would most likely be incorporated into cardiolipin? So you're given a combination here of different types of fatty acids. The key is we're told that the polyunsaturated fatty acids dominate, and which one would most likely be incorporated into cardiolipin. So we have to find the polyunsaturated fatty acids from the list. So how do we do it? Before we, dive right into it, there is a specific formula to actually determine which is saturated, which is monounsaturated, and which is polyunsaturated. So if I just get my pen out here, we can play around with, let's say, we can start with caproic acid. So let's just draw caproic acid out. So it's got 6 carbons and 12 hydrogens. So just bear in mind, one of the tricks of this question was that they included the carboxylic acid to trick you that, you might look at it and say there's 5 carbons. No, the carboxylic acid is part of the fatty acid. So you've got 6 carbons, 12 hydrogens. So let's draw that. We've got 1, 2, 3, 4, 5, 6 carbons. So we don't know yet if it's going to be saturated or unsaturated, but let's just put the bond there first. So we've got our carboxylic acid group over here. And now we're told that we've got 12 hydrogens. So we've already put 1 here, so we've got 11 to go. So straight away, you can see that, remember, carbon requires 4 bonds to it. So it's going to be 3 hydrogens here. It's going to be 2, 2, 2. So you can see how it's 1, 2, 3, 4, 1, 2, 3, 4 bonds. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got the 12 hydrogens here. That was lucky. So straight away, we know that this molecule, we don't have to change around the saturation. It's going to be a saturated molecule. So it's going to be a regular saturated fatty acid. So you can see here that it's got 6 carbons and 12 hydrogens. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, 6 carbons, and 2 oxygen atoms. So look, in your GAMSAT, you're not going to sit there and draw every single compound or fatty acid to try to figure out which one is saturated or unsaturated. There is a formula, as I alluded to earlier. So the formula is, well, if we take a look here, let's start off with saturated fatty acids. So our saturated fatty acid here has, so C. So we've got in the molecule, we've got C. So atoms C, O, and H. Let's put C, O, H. So this is for saturated. So we have 1, 2, 3, 4, 5, 6 carbons, and we have 12 hydrogens, which means if we've got represent the number of carbons as N, sorry, let me just rewrite this one, just make it easier to see here. So we make it H, there's going to be twice as many hydrogens as the carbon. So there's going to be 2N, and our oxygen stays the same, O2. So our formula for saturated fatty acids is CN, so number of carbons, H, 2N, so there's twice as many hydrogens, O2. So that's our formula. So if we can put this here, use this, when we look through the list here, we can try to figure out which ones are saturated. So you can do that if you want, pause the video and give it a go, or just wait a bit while we figure out the, I guess, equation or the formula for the unsaturated fatty acids. So if we want to figure that out, it's going to be, think about it. So if it's going to be a monounsaturated fatty acid, there's going to be one double bond in the chain. So if I change the color here, let's use a red color for double bonds. So let's just say I decide to put a double bond in this structure. Let me just put a double bond here. So we know that obviously the carbons can only have 4 atoms bonded to it, or just 4 bonds. So we've got here 1, so we've got 1, 2, 3, 4, 5 bonds here. So we have to get rid of a hydrogen. So what we do is, we just nick off a hydrogen here. So that one's fine. Now this carbon over here has 1, 2, 3, 4, 5. So we're going to nick off a hydrogen from this carbon, and there we go. So the structure now is complete, and it's nice and happy. So you can see now for a monounsaturated fatty acid, we have to remove 2 hydrogens. So therefore, we can write this as, for a monounsaturated, it's going to be, let's say, CHO2. So its carbon number hasn't changed, so it's going to be CN. Oxygen number hasn't changed, you still got 2. It's the hydrogen number that changed. So we had 2N to begin with, but now we've removed 2 hydrogens. So that's the key here. So a monounsaturated fatty acid has pretty much 2 less hydrogens than it's saturated for. So that's the best way to remember it. So again, you can look through the list and substitute these formulae to find which are saturated and which are monounsaturated. But finally, let's figure out polyunsaturated. So let's use a different color here. We'll use, I'll use green. So how about we include into this molecule, or to this fatty acid, we'll include another double bond. So that will make it poly because it's more than one. But how about we include another one? So let's just do 3 bonds here. So remember, carbon can only have 4 atoms bound to it, or 4 bonds. So if we're going to have a double bond here, we've got 1, 2, 3, 4, 5. So remove this hydrogen here. So over here as well, we've got 1, 2, 3, 4, 5, 6. So this carbon, we have to remove the hydrogen here. And we've got to remove the hydrogen here. And now we've got 1, 2, 3, 4. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Over here, this carbon's got 1, 2, 3, 4, 5. So we're going to remove a hydrogen here. There we go. So it should be 1, 2, 3, 4. Perfect. So you can see now that for this structure, we've removed those hydrogens to make it obviously happy. So we can generate an equation now. So carbons again, so let's say poly unsaturated. So we can see here that carbon hasn't changed, O2 hasn't changed, so carbon's still the same, hydrogen. Now, at the beginning we had 2n minus 2 for a monounsaturated. So if you include another double bond, you remove more, so you move 2 more. If you include another double bond, you remove 2 more than that. So we can represent that as 2x. So remember, N is for the number of carbons in a system, and X can be for the number of saturation. So that means this molecule is going to, if we've got 1, 2, 3, 4, 5, 6, so this fatty acid, we've got 6 carbons. That means it's going to be, there's going to be 2 by 6, which is 12 minus 2 by how many degrees of saturation? So there's 1, 2, 3. So it's going to be 12 minus 6. So that means there's going to be, so it's going to be a C6H6O2. So there's going to be 6 hydrogens in this molecule. So let's see. 1, 2, 3, 4, 5, 6. Perfect. So that's the equation here for a polyunsaturated fatty acid. So remember, you don't have to, in the exam, if you want to remember a formula, do it. But the best way to think about it is a monounsaturated fatty acid, because it has 1 double bond in the system, is going to have 2 less hydrogens. And a polyunsaturated fatty acid is going to have, again, 2 less hydrogens based on how many double bonds we have in the system. So if we have 1, 2, 3 double bonds, that means we're going to have 6 less hydrogens than our saturated form. Now that we have these formulae, try and see, you can pause the, I guess you can pause the video here and try to see if you can figure out what degrees of saturation are all of these fatty acids. So I'll give you a moment and then we can come back with the answer. So if you got propanoic acid is, you should have got propanoic acid is saturated, linoleic acid is going to be polyunsaturated, oleic acid is going to be monounsaturated, behenic is going to be saturated, enanthic is going to be saturated, Slavonic is going to be polyunsaturated, palmitoleic acid is going to be monounsaturated, stearic is going to be saturated, caproic is going to be saturated, and finally linoleic acid, which is the isomer of linoleic acid, is going to be a polyunsaturated fatty acid. So keep that in mind. So we've got that. When we read this, go back to question 1, it says which is most likely to be incorporated into chirality. So we have to find the polyunsaturated fatty acids in the list. So if we take a look here, let's say caproic and Slavonic. So we saw that caproic is going to be saturated, Slavonic is going to be polyunsaturated. So yes, there is 1 polyunsaturated, but it's not 2 polyunsaturated fatty acids. So let's keep going down the list. Enanthic is a saturated, whereas behenic is saturated. So these ones would most likely not be incorporated. We've got oleic acid and palmitoleic acid. So oleic is a unsaturated fatty acid, or it's a monounsaturated, whereas palmitoleic acid is a monounsaturated. So we've got 2 monounsaturated, which is great. But again, it's not 2 polyunsaturated fatty acids. And finally, we have here linoleic acid and linoleic acid, which are both polyunsaturated fatty acids. Therefore, to answer this question, it's asking which is most likely to be incorporated out of this list. Linoleic and linoleic are the only polyunsaturated fatty acids on the list. Therefore, they would most likely be incorporated. So the next question asked, due to its high content of fatty acids and its location to the electron transport chain, so that's the main site of reactive oxygen species production in the mitochondrion, cardiolipin is particularly prone to peroxidation. Using table 1, which fatty acid chain is most susceptible to peroxidation? Now, it's a very important concept in chemistry to understand that in any structure, if there's more sites for reaction to happen, therefore it's more likely going to be prone to that sort of reaction. So in this instance, if we're saying which species would be most likely peroxidized or oxidized, it pretty much means if you have more sites of oxidation, it's going to get oxidized more preferentially. And when it comes to fatty acids, one key thing to remember is that the more double bonds on the fatty acid, the more sites for oxidation, because the oxidation occurs at these double bond sites, which means you can intuit that polyunsaturated fatty acids are going to be more likely to get oxidized than monounsaturated fatty acids and obviously saturated fatty acids. So when we read this question, what we're looking for is obviously a progression from the most susceptible is going to be polyunsaturated fatty acids, where the least susceptible is going to be your saturated fatty acids. So if we take a look from the list, I mean, I like going up, down, up. I don't know, I just do it that way. You can look at it from up, down, but it's up to you. But if we take a quick look, let's just see the first fatty acids in the list. We can probably knock one off straight away. So savonic acid. So savonic acid we calculated before with a formula is going to be polyunsaturated fatty acid. So that's good. Looks like it's in a good position. Caproic acid. So it is going to be highly oxidized. Caproic acid is a saturated fatty acid. So straight away we know this is going to be a wrong answer, because if this is saturated, then linoleic acid is going to be a polyunsaturated. Caproic acid cannot be more highly oxidized than linoleic acid, because linoleic acid is a polyunsaturated fatty acid, whereas caproic is saturated. It doesn't have double bonds, so the sites for oxidation aren't there. So I mean, it can get oxidized, but it's going to be a lot less slower than linoleic acid, or less susceptible. So we know straight away that this is going to be incorrect answer. So we've got a polyunsaturated fatty acid up here, which is fantastic. Linoleic is polyunsaturated and linoleic is polyunsaturated, which is great. So it's either A, B, or D. So let's move to the next. So linoleic acid, we've got savonic acid here, which is a polyunsaturated fatty acid. So we've got two polyunsaturated fatty acids. Which one has more unsaturation? That's the key. So linoleic over here, where we got linoleic has 18 carbons, whereas savonic has 22 carbons. But you can see here that linoleic has 32 hydrogens, which means if we say double the amount of carbon, so that's going to be 36 carbons in linoleic acid, which means its saturated form should have 36 hydrogens. But if it's going to be unsaturated, it's going to remove 2 for a mono, 4 for a poly. So this is going to be a polyunsaturated with 2 double bonds, whereas our savonic acid is going to be a, remember, so we've got 22, so 22 times 2 is 44, so the saturated form is going to have 44 hydrogens, but we've got 22 carbons, so that means minus 12, so we've got, that means 2, 4, 6, 8, 10, 12, so we've got 6 double bonds here in savonic acid, which means savonic acid is going to be more susceptible, highly susceptible to peroxidation than linoleic acid. So this answer is going to be incorrect, because savonic acid should be here, linoleic should be here. Now, if you're confused, saying how did he get that so quickly, again, write out the formulae, try it out for yourself and see. Again, it's more conceptualizing, but it will come with time if you didn't get it straight away. So this is obviously incorrect. We said earlier that this is incorrect, so it's either between these two. So let's have a look. Linoleic acid is polyunsaturated, enanthic acid is a saturated, whereas palmitoleic acid is a monounsaturated. Therefore, saturated can't be more susceptible to peroxidation than the mono, so this is incorrect. So these three are incorrect. We're left with the top answer A, and we can just double check it by saying savonic acid is a polyunsaturated fatty acid, oleic acid is a monounsaturated fatty acid, and our enanthic acid is saturated. So therefore, our answer is A. So final question. Now this one, I love asking this sort of question to students because in the GAMSAT, they love asking these sorts of trick questions. So the question says, read it properly here. which statement regarding chiral construction is most true? When they say most true in a GAMSAT, it most likely means there's probably two questions or two statements in here that are correct, but one is more correct than the other one. Now, it's important to note here in the stimulus, we're told that cardiolipin preferentially prefers polyunsaturated species. It doesn't necessarily mean that all cardiolipin species are made up of polyunsaturated fatty acids. It just means that if they had the choice, they'd much rather have polyunsaturated than saturated and monounsaturated. It doesn't mean it's always going to be polyunsaturated. It could have combinations of mono to saturated to polyunsaturated, but just understand that this is where the trick comes. So if we read the statements here, it's telling us that cardiolipin is either going to be anionic or cationic phospholipid with two phosphatidyl moieties linked by a glycerol, which is either chiral or achiral. So if we walk through this question quickly, straight away we know that this molecule, it's a giveaway. It's going to be a phosphatidyl moiety, so it's going to be a phosphate. A phosphate's obviously in water, they deprotonate, and they are negative, so they're anionic, so an anion is negative charged, cation is positive, and it's a giveaway here. You can see in the structure there's a negative charge. So straight away you know the answer is going to be either A or D. So it's not going to be B or C because it says here it's cationic. That's wrong. So you're left with whether or not the structure is going to be chiral or achiral. So you look at the structure here, is it chiral? So let's take a look. We've got one group here. So here's our, carbon of interest. We've got a hydroxyl group. So that's, remember, chiral carbons have to have 4 different structures bound to the carbon. So we've got a hydroxyl group. That's different. The trick here also is that there's a hydrogen that's not shown in the structure. So there's a hydrogen here. So that's 2 structures. And now you've got 2 other groups. So 2 phosphatidyl moieties that look exactly the same on paper. Some students might see this and say, oh, look, it's achiral. There's symmetry, so it's wrong. But the question says which is most true. And the R groups here represent acyl chains, so different fatty acids. So this could be a saturated fatty acid, this could be polyunsaturated, this could be monounsaturated, this could be polyunsaturated. Remember, just because it says polyunsaturated dominates, doesn't necessarily mean it's always the case. And it doesn't necessarily mean the same polyunsaturated fatty acid species is going to be incorporated. You could have linoleic acid here with savonic acid, and over here you might have linoleic acid and savonic acid. So if you did have that combination, then it's obviously going to be a different structure here than here. So it's going to be a chiral carbon. So the fact that there's so many options to choose from, and there's probably dozens of different combinations, means that it's highly unlikely. I mean, it depends on the site-specific region, but it's highly unlikely it's going to be exactly the same. There's 4 different points for different fatty acids. So you're going to have different combinations, which means this side of the molecule is going to be different to this side of the molecule, which means we've got 1, 2, 3, and the hydrogen, 4 different groups, making this section a chiral carbon. So that's your answer. And try not to get confused, because in the GAMSAT, they love asking these questions. Try to make sure that you read the question properly and you pick the best answer. But that's the end for this session. Thanks for your time. If you do have any questions, you can pop them by in the comment section, and we're going to try to answer every single one of them. Or you can contact us directly, and we'd be happy to help. Thanks. Bye now.